Hey class, we're going to continue on our solving systems of linear equations here with our word problems. So follow along. We're on pages 297 and 298. Be sure you write down these 5 examples here. All right, so number 9, a business rents inline skates and bicycles. Inline skates cost $15 per day to rent. All right, so that's our first item. And bikes cost $30 per day to rent. All right, so I have 2 items, so I'm probably going to use standard form. One day, the businesses had a total of 25 rentals and made a total of $450. All right, so we got a couple of totals here. Calculate the number of pairs of skates rented and the number of bicycles rented. All right, and usually when doing these word problems, right, that last sentence is going to kind of help you identify your variables. All right, so in this case, we're talking about skates. So I'm going to make that my X variable. And I'm also talking about bikes. So I'm going to make that my Y variable. All right, so now that I identified my variables, right, I'm ready to set up those 2 equations, right? Again, we have 2 different items, so these equations are both going to be in standard form. So my first equation, I'm talking about the quantity or the number of skates. Well, we said the total was 25. All right, so this equals 25, and I'm talking about skates and bikes, right? I don't know how many skates and I don't know how many bikes, right? That's why I label them X and Y. So it's just going to be X, right, a certain amount of skates, plus Y, a certain amount of bikes, equals a total of 25. Right, so there's my first equation for the quantity or number, and now for the value or the cost, right, I have a total cost of $450. All right, well, how much does it cost? Well, I have that up here. It's going to be $15 per skate plus $30 for the bikes. All right, so now I have my 2 equations. All right, so now I'm ready to solve my system of equations to determine the number of pairs of skates and bicycles that were rented. All right, so I'm just going to kind of rewrite my equation below here. So we have X plus Y equals 25. And we have 15X plus 30Y is equal to 450. All right, now we can solve this a number of different ways, right? Kind of depending on what your preferred method is, right? We can do this either substitution or elimination. All right, for me, when I'm thinking I'm going to do substitution here and kind of get that X variable by itself, right? So to do that, I'm just going to subtract Y from both sides. And now I'm just going to rewrite my equation down here below. And we're going to get X is equal to 25 minus Y. All right, so now I'm ready to substitute 25 minus Y into my equation for X. So when I do that, I'm going to get 15 times the quantity of 25 minus Y is equal to 450 plus 30Y. I almost forgot that piece. Is equal to $450. All right, so now I'm ready to solve this equation for Y. All right, we're going to do that by distributing. And we're going to get 375 minus 15Y plus 30Y is equal to 450. All right, we're going to combine some like terms there. So we get 375 plus 15Y is equal to 450. All right, we're going to subtract 375 to both sides. And we get 15Y is equal to 75. And our last step is to divide by 15. And we get Y is equal to 5. All right, so we solve for Y. Now we just got to solve for X by just plugging that back in to our equation here, right? So we said X is equal to 25 minus 5 or x is equal to 20. Right, again, you could have solved this by elimination if that's what you preferred, but again, you would have got your same answers, right? We got x for 20 and y for 5. But again, we're not going to put these as an ordered pair, right? Because this is a word problem. So now we got to put a little context to a little meaning to our answers. So we're going to do that by writing out our answer to the question. All right, so they sold 20 skates. All right, we had x is skates, 20 skates, and we had 5 bikes. Now that is our solution. All right, let's look at our next situation or scenario here. Number 10, you're selling tickets to a football game. Student tickets cost $4 each, and general admission tickets cost $7 each. All right, so I got some student tickets at 4. I got some general admission tickets at 7, 2 different items. We're going to use standard form here. We sell 213 tickets and collect 1,146. All right, so we had a couple of totals here. So again, those are what these are. My equations are going to be equal to. All right, so we're going to write a system of equations again, right? But be sure to define our variables. Well, here, right, we're talking about student tickets, and we're talking about general admission tickets. All right, so X we're going to call student tickets. And Y is going to be that general admission tickets. General admission tickets. All right, so again, we have our variables defined. We're ready to write our equations. Again, we're talking about tickets, total tickets, and total costs, right? So that's what our two equations are going to be made of, right? So our quantity or total number of tickets, right? Again, we don't know how many students, and we don't know how many general admissions, but we do know there's a total of 213 tickets that were sold, right? X plus Y equals 213. And now for the cost, we know that they're $4 each, so 4X plus 7Y, right? $7 for those general admission tickets, and they brought in $1,146. So now we're ready to solve our system of equations, right? Using either substitution or elimination. So when I set this one up here, right, I'm looking at these two equations, this system here, and this time around, to me, when I see this, right, I'm thinking I could totally use elimination here, right? And I just need to multiply the top equation by -4, and I'll be able to set this up so that I can eliminate my x variable. So we get -4x minus 4y is equal to -852. Right, again, we could have done substitution here, right, by subtracting that y over, subtracting the x over. But to me, right, doing it elimination seemed a little bit easier. All right, but at the end, whether you do it elimination or substitution, we should get the same answer. All right, so we're going to add these two up, and my x's will eliminate. I get 3y is equal to 294, and I divide by 3, and we get y is equal to 98. I know y, now I just got to solve for x. Right, again, we're going to use the easier of the two equations, which is the top one of x plus y equals 213. So now it's going to be x plus 98 equals 213. And I just subtract 98 from both sides. And we get x is equal to 115. All right, again, that's not my final answer, right? I got to put it back into context, into some meaning. All right, so how many of each type of ticket was sold? Well, it was 115 student tickets, and 98 general admission tickets. general admission tickets. So there we go. And that is my solution. All right, moving on to page 298. All right, number 11, we have Beth here deciding between two cell phone plans. For 1 month, Plan Awesome charges $15 plus 10 cents per minute. Plan Fantastic charges $20 plus 5 cents per minute. So we have to write a system of equations to find the total cost as a function of the number of minutes. Be sure to define your variables. All right, well, again, this thing kind of defines our variables for us in that last sentence here, right? Total cost in number of minutes. All right, and as we said before many times in class, right, your x variable usually is for time, right? In this case, we're talking about minutes. These are a unit of time, right? And our y variable is usually our cost. So our dollars. All right, so now we have to write our two equations here for Plan Awesome and for Plan Fantastic, right? And if we read these sentences again, right, we see that our one Plan Awesome is $15 plus 10 cents per month, right? So there's that key word of that slope, right? Per, right? So this is going to be our slope-intercept form here. All right, so for Plan Awesome, it's going to be y is equal to 10x plus 15. Right, we got a starting initial charge of $15 and it's 10 cents per minute. And now for Plan Fantastic, right, they charge $20 plus 5 cents per minute. So y is equal to 5x plus 20. So those are going to be our two equations. And now for part B, after how many minutes, so we're solving for x, per month do the two cell phone plans cost the same? Right, in order to do this, right, I got to set them equal to each other, right? If they cost the same, it's like, when are they equal to each other, right? So I'm going to say, when does 10x plus 15, when does that equal 5x plus 20? All right, so now we're just going to solve this by subtracting 5x to both sides. So 5x plus 15 is equal to 20 minus 15. We get 5x is equal to 5, divide by 5, and you get x is equal to 1. All right, so after how many minutes per month do the two cell phone plans cost the same? It's just going to be after 1 minute. Right, if we wanted to, we can kind of graph these equations as well and kind of see like the long term, which one would be a better plan here. All right, so a couple more here. Number 12, we have a machine that heats up a single point by shining several lasers at it. The equations are y is equal to x plus 7 and y is equal to, or sorry, x plus 1 and y is equal to negative x plus 7 describes the path of the two laser beams. So we're going to graph both of the lines to find the coordinates of the heated point. All right, well, these are both in slope-intercept form, right? So we're going to graph these with our y-intercept at positive 1 for that first equation, and my slope is 1, right, because it's 1x, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, right? Put a couple points in there. All right, and then probably using a straight edge would be better. Going to go ahead and kind of connect those points. All right, so there's that first equation, and then that second equation of y equals negative x plus 7, right? Again, my y-intercept is a positive 7, so that's where I'm going to start graphing. And I have a slope of negative 1 this time because it's a negative x. So that means I'm going to go down 1 and 1 to the right, down 1 and 1 to the right, down 1 and 1 to the right. And we will have a solution here, right? That's where my 2 points intersect. And that solution is going to be 1, 2, 3, comma, 1, 2, 3, 4. All right, so if it's a graph and it's asking us to find the course of the heated point, then we can give an answer as an ordered pair of 3, comma, 4. All right, last problem here, number 13. All right, we're going to find the sum of two numbers is 26 and the difference is 12. So we're going to write a system of equations to find the two numbers. Hint, remember that sum means addition and difference means subtraction. All right, so again, we're looking for two numbers, right? So that's what our variables are going to be when we define them. All right, so we're going to say x is going to be that first number, right, whatever number that is. And then we're going to say our y variable is going to be that second number. All right, so now this time when we set up our equations, we're going to set up an equation for the sum of those two numbers, and we're going to set up an equation for the difference of those two numbers. All right, so for the sum of those two numbers, well, that's going to be my first number, x, plus my second number, y, is equal to 26, right? They add to 26, where the sum is 26. And then for the difference here, difference is 12. That means my first number minus my second number is 12. All right, so now that I set up these two equations, right, I'm going to have to solve for both of my variables here. Well, in this case, if I'm looking at my system here, right, probably elimination is probably going to be the quickest and easiest way to solve this one, right, because I have a positive y and a negative y. Right, so now I can just add these two equations up and solve for that first variable x. My y's are eliminated. So we get 2x is equal to 38. And now we're going to divide by 2 to get x is equal to 19. All right, so I solve for x. I just got to solve for y, right? Again, pick either one of those two equations to plug 19 into. I'm probably just going to do the first one because it's the positive one. So 19 plus y is equal to 26. Right, we're going to subtract 19. We get y is equal to 7. All right, so again, my answer is not going to be 19 comma 7, right? Because I have variables. I got defined variables. I got to put my answer with some context here. All right, so I'm going to say my first number is 19, right? Because that was my x. I'm going to say my second number is 7, right? And again, you can always double check. 19 plus 7 is 26. 19 minus 7 is 12. So we know that we have the right answer here. All right, so now you're ready to work on some homework here, which will be for your asynchronous day tomorrow, is to kind of work on those practice problems.